So I'm very pleased today to be talking with Professor Vinayak Dravid and Dr. Vikas Nandwana, both of the Department of Material Science and Engineering at Northwestern University. Professor Dravid is the Abraham Harris Professor of Material Science and Engineering at Northwestern, and Dr. Nandwana is a research associate and technical staff member in Professor Dravid's group. So welcome, both of you. We are specifically interested today in the OHM Smart Sponge that they have developed. This was awarded the third place at the IMAT-SCI Innovation Showcase competition at the 2019 MRS Fall Meeting. I should note that IMAT-SCI highlights new and innovative technologies, so that's excellent. They've recently published this work in the journal Industrial and Engineering Chemistry Research. So maybe Vinayak, I'll start with you. Can you describe what the OHM sponge is and why you call it a smart sponge?
Okay. So OHM stands for O is for oleophilic, that means a property that loves oil. H stands for hydrophobic, that means it hates water. And M stands for magnetic, so it can respond to external magnetic field. So OHM as a whole could also be pronounced as Om, which is, some of you may know of Indian mythology. It's a word has a very deep meaning. It's how the life started. It's the origin of universe with that phrase, Om. So it also stands for OHM, and we have it in the form of a sponge or a membrane. Because it's smart, because it's very selective. So if you have a mixture of oil and water, as is the case of oil spills, or is in the case of fracking products, there's so much fracking in throughout the world, particularly in North America, where there's a residual oil content in the water which you cannot dispose of without taking care of the oil first. So there are many scenarios where you have oil and water mixture. An OHM sponge or the OM sponge has the ability to absorb only the oil part in a mixture of oil and water. So it's smart in a sense that it recognizes that there's oils that can be sucked specifically and preferentially by the sponge, leave behind water. And the most important thing is the absorbed oil can be squeezed just like a regular household sponge, correct? So when there's a water spill in our kitchen, we take the sponge that's out there in the kitchen, we absorb the water, then we squeeze it in the sink and then reuse it. So here you can squeeze the oil, so you can recover the oil and reuse the sponge again and again. So the efficacy of the sponge is greatly enhanced by this ability of reusability. And it's smart because it absorbs oil preferentially in oil-water mixture. And other versions of this sponge will also absorb specific toxins and other dissolved nutrients. So you can think of the sponge as the platform or a platform technology, and we can tailor the platform to absorb oil in this particular case, but also other toxins and heavy metals. And that's what makes it a very smart sponge. It knows exactly what to suck up and recover. So because if you want to add something to this, I'm sure Gopal would be happy to hear.
So we call this has this 3 E's, it's economic, it's efficient, and it's eco-friendly also. So if we see the current methods, burning is one of them, dispersants, they all harm environment actually. So this is one solution which is not only cleaning the oil spill, it's cleaning in a clean way actually. So that's another point of this, that it does not have any disadvantages what the current methods have.
And so there's a lot of attention was given, including Coast Guards and other corporations, because oil spill, I was very surprised when I first got into the field a few years ago. And I realized that, typically we hear about oil spill, which in the evening news, like the Deep Horizon one that the NSF video starts off with. Or when I first came to America years ago, Exxon Valdez spill was in late 80s, was that iconic, terrible environmental disaster. But remarkably, there are oil spills of smaller nature throughout the world every day. So a few hundred gallon spills near the pipelines, in mechanic shops, small leaks in the boats and reservoirs. So there are many problems which involve oil leakage and oil mixing with water. And particularly, you've noticed the Flint situation with lead in water. There are many other secondary and tertiary effects of oil spill which are very detrimental downstream. So to be able to capture not only oil but also other toxin gives us a great advantage over the current technologies.
I like the name Ohm sponge.
Yes.
That really resonates, I think. If I could touch upon the M part in Ohm, I think to a material scientist, the nano coating is of great interest. So I was wondering if you could expound upon where the magnetic aspect of this helps.
Excellent. So the origin of the OHM, or the Ohm sponge, actually lies in the coating that you mentioned. So Ohm sponge has two parts. So you have the sponge, which is the substrate or the platform, the vehicle, and the nano coating that is imparted on the inside membrane, the pores of the sponge, are the active part. And the porosity offers a lot of permeability of fluids, so that allows a lot of contact area for the analytes or the toxins. And that affinity of the coating to oil is what makes OHM sponge so special. And we impart that ability through a combination of two major components. One is carbon-based substrate, which has the hydrophobic nature, and the magnetic nature of the particle imparts the M part of the OHM. So the M part, or the magnetic part, has two parts to it, two advantages. So one is, as you can imagine, that these are super paramagnetic nanostructures. So at room temperature, under normal circumstances, it is not magnetic. So it can be moved around, or it is just like any other nanostructure. But when you apply a magnetic field to it, the nanoparticle remember that they were magnetic before, so they respond to the magnet. So this is the demonstration I often show. So this is effectively the active component of the sponge, which is the nanocomposite slurry. And this is a magnet. As you can see, currently the slurry is just suspended, just like a regular suspension. But when you bring the magnet together, as you can see, it responds to the magnet. So when you remove the magnet, it disperses. So this is one property you can imagine would be very beneficial for oil spill recovery, because this OHM sponge, which are like this, they're sucking up the oil, then use a magnet to move them around or lift it, just the way they do it in the used car lot. You may remember some of the old James Bond movies. You press the car into a small box, then use an electromagnet to lift it and put it elsewhere. So a similar concept can be used to use a magnet to move around this magnetic pads. So that's one. Secondly, there's another property of this magnetic material which we use for biomedical purpose. So you asked me originally, what is the origin of OHM sponge? It started with this type of solution that we use to target Alzheimer's proteins or cancer cells in biology. Because these are tiny 5-10 nanometer particles. If we coat them with antibody, they go into a specific location, where this Alzheimer's or a cancer cell. And then they provide you with this additional functionality that if you apply an RF field, which is a typical few hundred kilohertz frequency, very readily available, very cheap, and it doesn't affect human tissues, these particles heat up 5 or 10 degrees above the body temperature. So in one case, when in our past work was target them to cancer, Alzheimer's, to cure the disease, in the case of OHM sponge, this heat dissolves the oil. So there's this additional functionality of the M part, which is ability to move that around, but also to use an RF field to warm the sponge so that you get more desorption or more recovery of the oil. And then you squeeze the oil, and then you're back to recapture the additional oil. So that is the M part of the OHM sponge.
Very interesting. Let me direct a question to Vikas. You're the co-founder and CTO of a company that I think is trying to take this technology to the marketplace. So how do you plan to scale this up for real world applications?
Since the release of since the publication, there have been a lot of interest, and even before the publication, we had a multi-prong approach that how would we go up and decide this problem. One of them is to work with the large-scale companies, the big oil companies actually. So we have been already in conversation with them, and what they have shown interest is they want to do a pilot testing at some of their test sites. So we want to start with that, and then the second approach is to work with these small companies, which are basically this oil spill response organization. These are contract-based companies, and these are the companies which do a lot of middleman work between the oil company and the customers. So we would like to work with them, and we would like to. We have got some interest from them also that they would like to use sponge, because currently either they use skimmers or sorbents, and especially with the sorbent there's a lot of physical waste, and they have shown interest because of the reusability of the sponge a lot. And in fact, the sponge can also be integrated with the skimmers. So we want to target some beachhead customers with them. And the recent development we have is the US Coast Guard also have shown an interest in this. So we definitely would like to work with them, and then that would increase the, I think, application a lot.
So there are two factors, Gopal, just to add to Vikas, and you asked about commercialization. So any commercialization of a problem that is a gigaton problem. I mean, look at oil spill. Those are massive. And what is not often known is when the spill happens, it spreads very quickly. So usually the spill is very thin, few millimeter, and it spreads kilometers and miles. So you need to initially stop the spread right away. And that is typically done with the booms. And so OHM sponge has the ability that it can be fabricated in any arbitrary shape. So one of the approaches is to make it into a boom, so you can restrict the spreading of the slick, oil slick. And the second part is to absorb only selectively the oil. So that would be done with OHM pads as in lieu of sorbents. Or so-called skimmers are basically cloth that rotates and skims the oil. But that's a very low capacity. But OHM sponge has almost 30 to 40 times absorption capacity of its weight, and it can be used several dozen times. So each sponge pad can do 400 times its own weight of recovery of oil. That is massive. So we are effectively 2 orders of magnitude efficient by any other techniques out there. And the key part to that is ability to make large quantities. And what Vikas has shown that his company, startup company, will commercialize a process called as flow reactor to make the solution which I showed you in large quantity with the same quality as this one. And that is the key process that the company will champion to make the OHM sponge.
Excellent, excellent. So, of course, you talked about oil spill remediation. Are there other applications beyond that you could use this material for?
Excellent question. So as you can imagine, Gopal, as we presented this work and showed it to others, especially your colleagues in industry, it's almost like you get a lot of, every day we get some application requests saying, can sponge help you do X, Y, Z? So we think of OHM sponge almost like a Swiss Army knife. You know, we have the Swiss Army knife concept because we have a different problem, you have a separate device. So you can imagine that OHM sponge as a platform, and currently our nanostructures have been imparted that property of oleophilicity and hydrophobicity. But in addition, you can tailor the active species to absorb heavy metals specifically. So you can imagine, in addition to sucking up oil, some component of this OHM sponge have affinity for, say, lead or mercury. Then you have the ability, in addition to oil spill, to capture this heavy metal species. Another area one of our students and she's working on is nutrients. So you might have noticed this massive algae bloom problem in many of our lakes, particularly Lake Erie, but also Gulf of Mexico. So what happens is a lot of the irrigated area, the farm area, have excess fertilizer, nitrates and phosphate. They get run off and then they get dumped into our reservoirs and aquifers. And there, excess phosphate and excess nitrate creates this algae bloom, because they get so much food that suddenly you get this proliferation of this green algae. And even from space, you can look how ugly thing there is, this very thick coating of green slime on lakes, which basically prevents sunlight to go further down, and fish and flora underneath is completely compromised. So this is a situation of excess nutrients going off into the waterways. So OHN sponge, with slight modification of its nanostructure, can absorb. We have shown in a Chicago water purification quality water, we can recover 95% of phosphorus from using OHN sponge. So we feel that OHN sponge is a beginning showing the oil recovery as one application. But tailoring OHN sponge, you have the ability to impart heavy metal sequestration properties, nutrient absorption properties, and the third area we are exploring is chromium-6 mitigation, which is a very carcinogen. You might have seen Eric Brockovich, that famous movie where she sues the P&G company and she deep dives into this chromium-6 problem. So we feel that OHN sponge has the ability to sequester chromium-6. So that will expand the ability of OHN sponge to impart many properties in water purification, and we're very excited by that.
So let me close by talking a little bit more about the coating material, the nanocomposite material. As a material scientist, we are constantly trying to improve properties of whatever materials we have, in addition to creating new materials. So can you comment on what your plans are for future research for the coating material itself?
Absolutely. So unlike biology, which I think with the COVID, I think we're all learning that biological interactions tend to be very specific. So there are certain biological recognition elements, that's what binding occurs. In the physical science and engineering, there is no specificity. So we need to develop innovative solutions of nanostructures such that they will have differential binding affinity for the toxins we need to remove. So our approach moving forward is to use the flow reactor to produce our active species, but we alter them or we make them more intelligent by imparting dopants. So these are tiny amounts that you can add to improve binding efficiency for specific ions like in lead or cadmium or mercury. So we feel that we have an approach whereby you can use the same platform such as the OHN sponge as a platform, but impart novel nanostructures so that we can tailor the sponge in different grades. Some grade for oil recovery, another grade for oil recovery plus say heavy metal recovery. A third grade is for water purification, and it's not in the form of a sponge, but in the form of a membrane. So we are excited that we have now might have found a gold mine, so to speak, that by making small variation in the active species of the OHN sponge, you can impart different functionality, and that again would expand our ability to clean environment beyond just the oil spill, but heavy metal and dissolved nutrients. And I think, Vikas, if you have any other you want to add to this?
Yeah, basically we're just starting with the water, but I think it has a broad scope for other type of environmental issue like the air pollution also. Because of the high porosity of the sponge, we can actually develop coatings based for the air pollution like particulate material as well as for soil remediation also. So
in fact, just to close that point, Gopal, is the material and the composite that makes up OHN sponge can also act as an antiviral coating. So as you can imagine, the coating is now being imparted on a cloth in order to make PPE, personal protection equipment, based on this concept of OHN sponge and the active species. So Vikas is developing what is called as a care mask. So cloth-based, antiviral, reusable mask. So this will have ability to use it, and it'll be antiviral properties to it. So this concept of a framework structure, highly porous, which is a sponge, decorated with active species for different application is, I think, is a concept that we've introduced with OHM span, which we feel is just the starting point of many great things to come.
Excellent. So Vinayak and Vikas, thank you so much for talking with me today. And on behalf
Thank you
of
very
MRS
much for
Bulletin,
your interest.